Welcome to Renew, the College of Forest Resources show that talks all about what we're doing in the College of Forest Resources. And we really promote and conserve and utilize our natural resources for the benefit of all. And today we have guests from the Department of Sustainable Bioproducts. Dr. Joe Lopez and Mr. Edward Insminger, welcome to our show.
Thanks for having us.
Thank you.
And today we are going to talk about some work that you all are doing with adhesives. So first of all, let's talk about what are adhesives, why do we use them?
Well, basically we use adhesives in from your bed to your civil construction. So we use plywood, OSB, laminated veneer lumber, cross-laminated lumber, which is a new engineered product. So you can think of, we have several segments in our industry, in society that make use of those products.
Okay, great. And so normally those products, wood products like plywood, veneer, they're glued together. So they're wood, could be wood pieces or it could be wood sheets that are glued together.
Yes,
and right now in the industry we're using formaldehyde, is that right?
That is correct. I think the most commonly used wood adhesive in the wood composite industry are formaldehyde based. More specifically, urea formaldehyde due to its low cost, rapid curing, and bonding strength. However, I think it was in late 2000s, the World Health Organization reclassified those formaldehyde compounds as carcinogenic. So as you can imagine, there is a current pressing need to develop bio-based formaldehyde-free wood adhesives.
Okay, and so y'all are using natural products to make these adhesives, which are made from natural resources, our wood. So let's talk about what adhesives y'all are working with right now.
Oh yeah, so basically you're working on a novel adhesive that is made from cottonseed. Edward and I, we have been testing these adhesives following national and international standards for water bath and shear strength. We have achieved comparable or similar results to what we have in the industry right now in terms of bio-based adhesives. The bio-based adhesive now in industry is soy, and I think with this research we have capabilities to expand that to bring down the press time, hot press time, so that we can be more competitive.
Okay, so right now in the industry we're using soy.
Yeah.
It's somewhat. And so we're introducing cottonseed.
That is correct.
As an adhesive. And how is cottonseed used now?
Well, the primary use of cottonseed is to feed dairy cows because most of the animals, they cannot process the toxic compounds present in the seeds. Okay.
So it's used as a supplement in feed, not strictly.
That is correct.
Right. And so it's kind of a undervalued product.
That is correct.
Maybe.
Also, yeah.
So we're going to take a low use product and turn it into perhaps a high quality product with our plywood and our wood adhesives.
Yeah,
right?
Think about this. We have a lot of investment in cotton production in the southeastern United States, correct? So we can perhaps give our stakeholders a new alternative for their product.
Okay, great. Yeah. So tell me the process that you all go through to make the panels and then test them.
Yeah, so we first start by using cottonseed itself. Way that it's extracted is they take the fiber from the cotton and then they only use the seed component itself. They grind that seed up and that turns into the meal that we use. We also add DI water, the deionized water to the mix, and then we add two additional ingredients. One being a catalyst. It's called sodium metabisulfite, and that kind of helps bind everything together into the adhesive itself. And then the last ingredient that we use is a product called PAAE chymine. It's got a long word to it. I can't really say the long word. It's just so elaborate, so scientific. But those are the four ingredients that we use, and that chymine is basically used as a water resistance. It helps enhance the adhesive against water.
Okay.
And so this is mainly used because as the plywood is going to be used in interior applications, like in your homes and in industries and stuff like that, then you want to make sure that any kind of humidity or the fluctuation of temperature or maybe a pipe burst in your house, you want that plywood to resist any kind of water damage that could happen over time. And so we go through, like Dr. Lopez mentioned, we go through these water bath scenarios that we actually test the samples to check for resistance.
And you brought some samples,
I did,
right?
yes.
Let's see what you brought
Yes.
that we can talk about.
And so these are two examples of basically the international standard that requires any plywood to be checked for water resistance. And they're cut 2 inches by 5 inches long. This one right here, where I have all these red marks at, it basically shows that you can see that it's delaminated. It has come apart from the veneers, the ply itself.
Which means the adhesive is not working, is that correct?
Yes, that means that it's failing. And I have a little feeler gauge here, and based off of the standard, if it goes to 1/4 inch deep or more, then for an extended, for 2 inches long period, then that is considered a failed sample.
Now, do we know why the sample failed? I mean, are there multiple reasons why it could fail?
I would say it's because of bad adhesion.
Okay.
Yep.
It could have something to do with moisture content in the wood. Maybe there was a knot or something, but you can see that these don't have any kind of defects in them whatsoever. So we try to keep really good quality veneer when we're making these plywoods.
Okay.
But that's one example of a test that we have to conduct on a piece of plywood. Another test that we do from one panel, we conduct 6 of those, and then we also make these small samples, these 1 inch by 3 inch samples, and these are called your shear samples. They're cut a little bit because we're pulling the sample apart like this to try to see how strong the adhesive is versus the wood itself. This one kind of poor quality, not a lot of wood damage, so maybe a little more of an adhesive failure there. Whereas this sample here from a different batch had a lot of wood failure, which is really good because that means the adhesive is stronger than the wood itself.
And that's what we're aiming for,
That's
right?
Yes, ma'am.
Yeah.
Okay.
So these are 2 tests that we conduct on an actual piece of plywood itself. When we get done with putting the adhesive on the veneers and orienting the middle veneer in the opposite direction to make plywood, then this is what our panel basically turns out to be. It's a hardwood veneer, it's yellow poplar, and we're using the bio-based cottonseed adhesive to bind it together. We're finding good results with it, and that's basically an example of our plywood.
Are you all testing for any kind of insect damage? Since it's interior, is there a need to test for insect damage?
Yeah, actually, we just hired a new graduate student where we are going to test these panels against some fungi that is common in the United States, especially brown rot fungi and white rot fungi.
Well, when you think about cottonseed or soybean, it's a food, based product, so you would think that might draw insects. So it's interesting to know, does it draw insects? Is there a way you treat it for insects? So y'all are going to start on that research then?
That is correct. You're going to start on that research and hopefully we'll find out how the degradation happens in those kind of panels.
Okay. And you also brought some pictures that we want to show of the kind of the process. Is that right?
Yes. Yeah, that'd be great.
Okay.
So here, this first picture that we're looking at is the actual cottonseed meal itself. It's real fine. That's the raw form of it. Nothing's really been done to it besides it's ground up into a real fine pulp. This next image here shows our 4 ingredients, as I mentioned before. We have the cottonseed on the far right. We have the deionized water there in the slightly smaller beaker. We have our chymine, that's kind of that amber colored. And then on the far left, in the smaller beaker, is our sodium metabisulfite.
And that's the ingredients.
Those are the four
Yes.
ingredients. Yeah, that's
Okay.
right. That's correct. Here we've added them all together, and now we're mixing them up using a blender or a mixer, and we make sure that it's mixed up very well and there's no separation or no clumps or anything like that. This picture here shows us testing for not only the temperature of the adhesive, because that can play a role, but also how the viscosity of it, how thick it is or how thin it is. And we also want to see, if it's too thick, like peanut butter, you can't really apply it very properly. If it's too thin, like water, then it may not stick to the veneers properly.
Okay.
Here's an example of us applying the adhesive to a piece of veneer. We're just using a roller, which is very similar in the industry. They can also, in the industry, they'll also kind of spread it out using like nozzles and kind of spray it on the veneer. After we've put all the pieces together, then we cold press it for about 5 minutes, as the standard does, and then we also put it into a hot press for anywhere from 4 to 7 minutes at 180 psi. And this is an example of us pulling out a big sheet of plywood.
Great, great. So the $1 million question, lumber prices right now are through the roof. And so do we expect that this technology would cost more to produce or cost less to produce when we're looking at plywood and particle board?
Well, I think that initially, because of you have to build the plants and plan about the resources, the cost will be really high. But as we mass produce those panels and as we gather those resources, I think the cost to produce this kind of technology will definitely go down.
Awesome. That's always good news to homeowners. And we certainly appreciate y'all coming and talking about the process. And it's so interesting. And our Department of Sustainable Bioproducts is doing great work to extend lumber, these natural resources that we have. If they can extend the use of these natural resources, then we have more. And so we sure do appreciate you coming. Thank you all for joining us for Renew. I'm filling in for our guest, Leslie Berger. I'm Karen Brazier, and we hope to see you next time.